Now you might be wondering, why on earth is a 16-year-old really interested in pancreatic cancer? I mean, it's one of those obscure cancers. And I actually became interested because a close family friend passed from the disease when I was 13 years old. And then what I found is that 85% of all pancreatic cancers are diagnosed late, when someone has less than a 2% chance of survival. And we really have no current standard of diagnostics. Our current standard is an $800 per test technique that also misses 30% of all cancers and hasn't been updated in over 6 decades. So then I decided to go and strive towards revolutionizing pancreatic cancer diagnostics with my armory of knowledge from 9th grade biology. And so I went to a 13-year-old's best friends for knowledge, Google and Wikipedia, how to get through every high school test. And essentially what happened is I looked up what these different proteins are found in your bloodstream when you have these different cancers. And I stumbled across this database of over 8,000 different proteins that are found in your bloodstream when you have pancreatic cancer. So I just started plugging and chugging through this, and on the 4,000th try, I finally found a protein called mesothelin that just might work. And mesothelin is just your ordinary run-of-the-mill type protein, unless you have pancreatic, ovarian, and lung cancer, in which case it's found at these very high levels in your bloodstream. But also, the key is that it's found in the earliest stage, when someone has close to a 100% chance of survival. So then that I had found a really reliable biomarker for pancreatic cancer, I shifted my focus to actually detecting that. And my breakthrough came in the most unlikely of places. High school biology class, in my opinion, the absolute stifler of innovation. And I had snuck in this article on what are called single-walled carbon nanotubes. And that sounds like a big, complicated name, but they're really simple. They're just these long, thin pipes of carbon that are an atom thick and 1/50,000th the diameter of your hair. Yet, despite their small size, they have these incredible properties. They're kind of like the superheroes of material science. And we're learning about antibodies, essentially molecules that only react with one protein, in this case, a cancer biomarker. And what I thought is, if I weave these antibodies into this network of carbon nanotubes, then you would have a network that would only react with one protein. But also, due to the properties of carbon nanotubes, you would have a network that would only change its properties, its electrical properties, in the presence of that protein, and thus detect pancreatic cancer. And it's actually very simple to produce. It's kind of like making chocolate chip cookies, which I love. You start with some water, you pour in the carbon nanotubes, pour in the antibodies, mix it up, take some paper, dip it, dry it, and then you can detect cancer.